This video introduces routing types and principles supported by the device. Routing is one of the fundamental elements of data communication networks. Routing information defines the path for packet forwarding. The routing process refers to the forwarding process of packets. The device supports the following routing types. Static routing. Fixed paths are manually configured, which applies to environments with a stable network structure. Packets are forwarded based on configured information, including the destination address, next hop address, and outbound interface. When multiple static routes with the same destination address are configured, you can set their priorities for packet forwarding. Intelligent routing. Intelligent routing supports various policies such as policy-based routing and application-based routing. Packets can be forwarded based on policy configuration. Based on intelligent routing, the packets that meet the matching conditions can be forwarded to the specified outbound interface or next hop. When multiple intelligent routing policies exist, the closer a policy is to the top, the higher its priority in matching. Address library routing. You can add a custom ISP address library and associate it with a specified interface. Data flows will be automatically routed based on the ISP address library to avoid cross-ISP access and achieve faster network access. Dynamic routing. Paths are automatically learned and updated through routing protocols, which applies to environments where the network structure changes frequently. Default route. A default route is the path used when no specific route matches. Typically, it is destined for a default gateway. If multiple routes are available, the routes are selected based on the following rules in descending order of priority: intelligent routing, static routing, dynamic routing, address library routing, and default route. Here, intelligent routing and static routing are demonstrated. The following uses a typical scenario to describe how to configure intelligent routing and static routing. As shown in the figure, a device is deployed at the border of subnet 1, and subnet 1 and subnet 2 access each other through the device. A web application server is deployed on the ISP network. Traffic destined for the web application server needs to be forwarded through the one interface GE0/1 on the device. The following configuration uses this topology as an example. Make adjustments according to the network planning and requirements of the actual scenario. Choose Network Routing/Load Balancing Intelligent Routing. Click Create. Enter a name. Set the inbound interface to the LAN interface GE0/2 of subnet 1. Set the destination address to the domain name of the web application server. For app, select the custom application custom web server. Set action option to forwarding. Set egress line type to single interface. Set egress line to GE0/1. Use the default configuration for the other parameters. Click Save. Configure a static route from subnet 1 to subnet 2 on the device as follows. Choose Network Routing Load Balancing Static Routing and click the IPv4 tab page. Click Create. Set dest IP range mask to 192.168.1.0/24. Set interface to GE0/6. Use the default configuration for the other parameters. Click Save. In addition, you need to configure a static route from subnet 2 to subnet 1 on the router, which is not shown in this video. After the device has been running for a period of time, choose ONM logs a session log. The traffic of users on subnet 1 destined for the web application server is all forwarded by GE0/1, and the traffic destined for subnet 2 is all forwarded by GE0/6. Thank you for watching.